We deal with the transportation problem. Transportation problem is aimed at finding the minimum total transportation cost of an organization. Say if an organization has multiple warehouses or depots, then if it has to supply the materials from its multiple warehouses or depots to retailers, or from multiple companies to various wholesalers or distributors or warehouses. In that case, say let us say there are 4 warehouses and 6 retailers. In that case, from warehouse 1, warehouse 2, warehouse 3, warehouse 4, they can send the material to retailer 1, retailer 2, retailer 3, retailer 4, retailer 5, retailer 6. But the cost will vary. If we supply the material from warehouse 1 to R1, W1 to R1, W2 to W1 to R2, W1 to R3, W1 to R4. Likewise, when we will have the cost associated for transporting 1 unit of that is given in the problem. Then similarly for W2, warehouse 2 to R1, retailer 1, R2, R3, R4, R5, R6. Likewise, for all the warehouses, the values are given. Not necessarily 4 and 6, there may be 4 warehouses, 4 retailers, or 4 companies, or 5 distributors, likewise any number. But the cost associated from one to other is given. So this will be represented in a table or format, and apart from that we have the supply from warehouses or supply from factories, and the demand at warehouses or demand at the retailers, or likewise that is given, the data is given in the problem. We should try to supply the material which should result in the lowest cost. So we have 3 methods basically. First one is northwest corner method. It is not a scientific method. Actually, it was the first method that is followed. It was only crude method, and it will not result in the lowest cost. In the northwest corner method, we see for every table, a transportation table, you will find there are cells, and each cell is comprising some number, which is the cost associated with transporting from one place to other place. And at bottom you will find the demand at each place, and at right side you will find the supplies from either factories or warehouses or depots that are given. So if the total of supplies is equal to total demand or requirement, then it is known as a balanced problem. But in case if the supply is not equal to demand, or that means supply is more than demand, or demand is more than supply, in such situation we call that as unbalanced problem. However, we will see first what is the balanced problem and how we are going to solve. So in the table given, we will identify with the values whichever is the most extreme northwest corner cell. So we will, based upon the demand in relation to that cell and availability in relation to that cell, we will try to allocate maximum possible number of units. If the demand is satisfied, we cannot make any allocation in that column, right, because that is satisfied. Or if the total number of units are exhausted in relation to that in that row, then we cannot make any allocation because there are no units available, so that row becomes irrelevant or redundant. So then we will see, based upon the situation, what is the remaining table, and then for the remaining table we will find out northwest corner cell. Then we will make again some allocation number of units based upon demand and supply. Likewise, we continue. Here the key is only identifying northwest corner cell and making an allocation till all the units are being allocated based upon demand and supply relationship. Then we will try to find out the total cost of transportation. because how many units are being allocated to each cell. In each cell the number is cost is represented by some number, that multiplied by number of units. Likewise we calculate total number of units multiplied by their relative cost, and we will get the total cost of transportation. Then next method, which is scientific in its approach and which is known as least cost method. In least cost method, simply as the name itself indicates, for any given table or transportation table or matrix, we try to identify the least cost in the entire table and try to allocate as maximum units as possible, so that then we'll see whether demand is satisfied or supply is completely exhausted. Then we'll identify next least cost. Then there we'll also make allocation based upon the availability, based upon the demand. Then we'll move on. We'll find out next least cost. Likewise, we keep on searching for least cost in the table. Then we try to allocate maximum number of units. Then we'll find out the total transportation cost. Then we have Vogles approximation method, or we also call that as VAN, Vogles approximation method or VAN method. In this VAN method, what we try to do is, we try to write down the row penalties and column penalties. What row penalties indicates is, first row we'll check, we'll identify the lowest cost, then next lowest cost in the same row, and we'll write down there. Beside that, we call that as row penalty. Then next row will go, next row will check, in that what is the lowest cost, next lowest cost, difference between those two. If difference of those two is 0, we'll write down 0. If both are equal, we'll write down 0. And if there is a difference, let us say 3 and 4 are there, then the difference is 1. Lowest is the 3, next lowest is 4. Difference is 1, we'll write down. Likewise, for all the rows, we'll write row penalties. Then in column penalties, we'll check with the first column. Then what is the lowest and next lowest, we'll write down. Then second column, third column, fourth column. Likewise, we'll write down the penalties. Then we identify in both the row penalties and column penalties, wherever the maximum penalty is occurring, we choose that either row or penalty. When we are saying all penalties, row penalties are considered and column penalties are considered. Among them, whichever gives us highest penalty, in that respective column or column or row, we try to make allocation by looking at the lowest value in that. Then after that is over, demand or supply is satisfied, or supply is satisfied, or demand is satisfied, then that will become redundant. Then for the remaining rows or remaining columns, we keep on writing penalties. Then again we'll identify the maximum penalty in row or column. Then we'll make allocation. Then again we'll go likewise till entire allocation is done. We'll continue with the Vogles approximation method. Once that is completed, we try to compute the total cost. These penalties are representing simply the logic here is, in case if we are not going to allocate to the lowest cost cell, in next choice would be next lowest cost cell, which will result in that kind of penalty. The logic behind drawing up column penalties and row penalties is that. So we try to avoid maximum penalties. That is the reason we have chosen highest penalty rows or highest penalty columns, and there we are going to make allocation.